Hello, my name is Yoojung Kim, and in this video, I will be presenting the article Virtual Core Flow Cytometry by Swalwell et al. Flow cytometers are able to characterize and accurately measure a sample consisting of particles or cells by using a focused laser beam to detect fluorescence or scattered light. However, in order to analyze samples accurately, the particles must be positioned consistently in a stream. Methods to do this include hydrodynamic focusing, dielectrophoretic focusing, capillaries, and acoustic focusing. Of these methods, the most commonly used one in commercial flow cytometry is hydrodynamic focusing. Hydrodynamic focusing involves the use of sheath fluid, which is used to force the particles to travel in a laminar flow as single cells, making a core stream which allows the focused laser beam to focus on one particle at a time. However, this method requires a lot of fluid, and once used, it cannot be reused. Therefore, it is difficult for applications that involve going out to the field, such as environmental monitoring and point-of-care devices that bring medical or diagnostics to remote populations. In order to make flow cytometry independent of sheath fluid, Jared Swalwell's group was able to use 3 photodetectors to create a virtual core stream. The fluorescent or scattered light passes through the pinhole mirror, and the position detectors determine if the particle was correctly positioned and usable for analysis. Light that comes in as a result of a particle that was in the center of the stream will pass through the pinhole undeviated. However, if the light is a result of a particle that is not in the center of the stream, it will be detected by one or all 3 of the position detectors. The process described in the previous slide creates a virtual core, where only the particles in the center of the core are considered or measured. The virtual core is a result of measurements from all 3 detectors. To test and validate their system, the group compared measurements done on a traditional flow cytometer and their own on test particles, immunofluorescently labeled thymocytes, and raw seawater. When CD4 and CD8 expression in murine thymocytes was analyzed using traditional flow cytometry compared to VCFC, or virtual core flow cytometry, they found a less than 2% difference in results after applying a gate that determines the virtual core. Not only was this method able to recover the general morphology of the traditional plot, but it was also used quantitatively. In addition, when they tested their method on raw seawater, they were able to distinguish the populations of phytoplankton as shown as well in the traditional method, as well as the 1 and 6 micron beads they used for calibration. In conclusion, VCFC was shown to be accurate enough that its results were less than 2% different from traditional flow cytometry utilizing a fluid sheath. Therefore, they eliminated the need for fluid and opened up the possibility for a mobile flow cytometer that can be taken into the field for environmental monitoring and medical diagnosis for remote populations. Some considerations for future work include comparing VCFC's results to other focusing methods, since those also don't require a fluid sheath. How does it stack up in translational potential compared to those already in the market? Additionally, how stable is the system? I noticed that they did not include the variability of the system, which is important in not only delivering accurate results, but also a robust mobile system that can be taken out into the field. Thank you for listening.